Today, our topic is machine learning for information retrieval. Uh, I'll be discussing how machine learning is used in information retrieval. Machine learning allows information retrieval systems to improve by learning from data, enabling them to deliver more relevant and accurate search results. Machine learning based information retrieval goes beyond traditional keyword matching by understanding context, patterns, and user behavior, which are essential for modern search engines. Here our team members are Gopichandra and myself. Now coming to introduction to machine learning. Here, machine learning is the use of algorithms to identify patterns in data and make predictions. In information retrieval, machine learning helps systems to retrieve relevant information based on learned patterns. There are three main types of machine learning in information retrieval. Those are supervised, unsupervised, and reinforcement learning. Supervised learning uses labeled data, and unsupervised learning finds hidden patterns without labels, and reinforcement learning learns from rewards of feedback. Each of these types plays a unique role in making information retrieval systems more efficient and accurate. Now, coming to traditional IR versus machine learning based information retrieval. Here, traditional information retrieval relies on methods like keyword matching, where the search system retrieves documents based on exact matches to the user's query. And this approach is limited because it often misses the context and fails to fully understand user intent. And machine learning, on the other hand, allows information retrieval systems to recognize relationships between words, understand context, and even learn from the past user interactions. This makes learning based information retrieval systems more accurate and capable of providing relevant results. And here it comes supervised learning for information retrieval. In this, it involves training a model on labeled data where each example has a known outcome. In information retrieval, supervised learning is used to classify documents or predict user intent based on previous queries and interactions. For example, models can classify documents by topic or identify query intent to improve search relevance. This process allows information retrieval systems to be trained to understand which documents or search results are most relevant to specific queries. And next one is unsupervised learning for information retrieval. Here, it doesn't use labeled data. Instead, it finds patterns or clusters in data. In information retrieval, unsupervised learning helps organize information and group similar documents. For example, clustering is used to group documents with similar topics, and topic modeling identifies themes within large datasets. This type of learning is valuable in information retrieval for organizing and managing large amounts of unstructured data. And next one is reinforcement learning for information retrieval. Here in reinforcement learning, it's a type of machine learning where models learn by receiving rewards or penalties based on their actions. In information retrieval, reinforcement learning allows search systems to improve by learning from user feedback, like clicks or interaction time. For example, if users frequently click on certain types of results, the system learns to prioritize similar documents. Where reinforcement learning is useful in tasks like personalized search, where search results adapt to the user's preferences over time. And next to coming to feature engineering in machine learning based IR. Here, feature engineering is the process of selecting and creating relevant features from raw data to improve the model's performance. In machine learning based information retrieval, feature engineering might involve selecting variables like word frequency, term importance, and document length. These features will also help the machine learning model understand what parts of a query or document are most important, improving the accuracy and relevance of search results. Next one, embedding representations in machine learning for information retrieval. Here, what are embeddings? Embeddings are numerical representations or words or documents that capture meaning and context. In machine learning, for information retrieval, embeddings allow models to measure similarity between terms based on context. For example, Words that appear in similar contexts, like doctor and physician, will have similar embeddings. This means the system can retrieve documents that are contextually similar to the query, even if they don't use the same words. Next one, learning to rank in machine learning for IR. Here, we can see the purpose of learning to rank and approaches for that. First one, learning to rank is a supervised learning. This is an approach where we use it to order documents by their relevance to a query. So, there are three different approaches to learning to rank. First one is point wise, second one is pair wise, and the last one is list wise. First, point wise considers each document individually. Pairwise compares two documents at a time. And whereas list-wise, it evaluates an entire list of documents, and where this helps information retrieval systems to ensure that the most relevant documents appear at the top of the search results. This is the learning to rank process in machine learning for information retrieval. Next one is query expansion with machine learning. Here, query expansion involves broadening a user's query by adding related terms or synonyms, by making it easier to retrieve relevant results. Machine learning based query expansion uses models where it uses to identify related terms, improving search coverage. For example, if a user searches for a heart disease, then machine learning comes into picture, and the models of the machine learning might expand the query to include terms like cardiovascular disease or heart conditions, or all the relevant words related to the heart problems. This helps the system finds more relevant documents. And next, my teammate will continue.
Natural language processing NLP techniques in IR. The natural language processing or NLP is critical in IR because it allows system to understand human language. NLP techniques such as named entity recognition, sentiment analysis, and text summarization help models analyze both queries and documents. These techniques allow IR systems to extract important information from text, understand query intent, and returns results that match the user's needs more closely. The next slide is evaluation metrics for machine learning based IR. Evaluation metrics are essential for measuring how well ML based IR systems perform. Common metrics include precision, recall, F1 score, and NDCG. Precision measures how many of the retrieved cumulative gain evaluates the ranking quality by prioritizing relevant documents at the top. These metrics help ensure that IR systems deliver accurate and useful results. And the next slide is challenges in applying machine learning to information retrieval. These are several challenges when applying machine learning to information retrieval. First, machine learning models require large amounts of labeled data to perform well, which can be difficult to gather and maintain. And the second thing is machine learning models are computationally demanding, especially for large scale systems, which require significant processing power and memory. The other challenge is adaptability. Machine learning models need to be updated frequently to stay relevant as user behavior information changes. Next slide is case study. Google's use of machine learning in search. Google has integrated machine learning into its search engine to improve relevance and understand user intent. For example, Google's RankBrain algorithm uses machine learning to interpret complex or ambiguous queries based on patterns from past searches. RankBrain can understand what the user likely means even if the exact terms are not in the document. This helps deliver more relevant results for a wide range of search queries. Next slide is case study. Amazon's uses of machine learning in product of search. Amazon uses machine learning in its product search to deliver relevant queries. Amazon algorithms analyze product details, user preferences, and past purchases to suggest items that match the query. For example, if a user often searches for organic skincare, Amazon's machine learning models prioritize similar products. This helps improve customer satisfaction and increase sales by recommending relevant products. And the next slide is future trends in machine learning for information retrieval. The future of machine learning in information retrieval includes trends like personalized search, where search results are tailored to individual users, and multimodal AI, where systems retrieve information across text, images, and videos. Unsupervised reinforcement learning advancements will also make AI systems more responsible to complex queries and adaptable in real time. These trends aim to make information retrieval to more intuitive, relevant, and user centered. And my friend will continue.
Next one, ethics and fairness in machine learning based information retrievals. Here we have bias in machine learning models and ensuring its fairness. Here, as machine learning is used in information retrieval, the main thing is ethical considerations become more important here. So, machine learning models can inherit biases from training data, which leads to biased information retrieval that results the prioritize certain viewpoints or exclude others. Here, to address this, it is essential to use balanced data sets that are regularly monitored for bias, and also it ensures the fairness, which is critical to building information retrieval systems that serve all users equitably, and also it avoids reinforcing the harmful biases. Here we summarize the topic, and here are the key takeaways. To summarize this, mainly machine learning has significantly improved information retrieval by allowing systems to learn from data and also to improve its relevance. Here, the techniques like supervised learning, which is query expansion and learning to rank, this all will help us information retrieval systems to deliver better search results. So, machine learning based information retrieval here it offers a flexible and adaptable approach that goes beyond the traditional keyword matching to provide more accurate, relevant, and user focused search experiences. The conclusion is machine learning in information retrieval continues to evolve, and by setting new standards for how these will retrieve information and will search systems meet our user needs. And for these future directions and closing remarks, by looking forward, our machine learning will continue to shape information retrieval, making search systems smarter and more adaptable. Here, the advances in personalization, multimodal retrieval, and fair A- AI practices will make information retrieval systems even more effective in meeting diverse user needs. So, here I'm happy to answer any questions about machine learning in information retrieval, where the field is headed. And thank you for your attention.